This question started with giving us an example reaction where carbonyl compounds, when react with HCN in the presence of a weak base, will form hydroxynitrile. In the presence of a weak base, HCN will actually generate cyanide ion, and then this cyanide ion will later start the reaction to react with the partial positive carbon here. New bond formed between the C and CN, and the H here, okay, will be accepted by the oxygen and form a hydroxyl group. Now, they say that we are supposed to use this for a similar reaction. The similar reaction, we have CH3CO2CH3 replacing the HCN in this equation. And in the presence of a strong base, ester molecule will generate an N-ion. So just like HCN in the presence of a weak base will generate an N-ion. Okay, also losing a H. So that means this H will later be accepted by the carbonyl O also to form hydroxyl group. So now let's write an equation similar to the example given. Okay, C, double bond O, okay, R. Now in this case, they say which compound can be made from an aldehyde. Okay, so I'll put H here because aldehyde means the functional group is bonded to one hydrogen and the other one will be an alkyl group. Reacting with ester CH3CO2CH3 in the presence of a strong base, it will generate, okay, an N-ion CH2 negative CO2CH3. So what is the product that is formed? Right, C. Can you see from this example, these two alkyl groups didn't change throughout the whole experiment. So this R and this H group shouldn't change also. So just copy it down, R and H. So in the product, the O accepted the H and become OH. So where does this H come from? Now see, this ester lost a H plus and formed this N-ion. So the H plus is actually accepted by the O and becomes OH. Double bond no more, became single bond. So this also became single bond. So what is this group here, this new group here? See, from the N-ion. So that means this will be from the N-ion also. CH2, CO2, CH3. So this will be the product. So we have written the equation to show the formation of product. Now let's check all the answers A, B, C, D, which compound can be made, okay, from this reaction. Compound A, I have CH, OH, CO2, CH3. Now CH, okay, from here, CH, which is correct. OH, correct, okay, OH. CO2CH3, okay, this part is incorrect. Why? Because from the base, there's a CH2, CO2, CH3, so missing of the CH2 in the middle. So A is not correct. Now let's look at B. B, I have the CH, which is correct, CH. Okay, OH, this CH is bonded to OH, right, which is also correct. Then, what about this base functional group? I have the CH2CO2CH3. Right, now this part is incorrect because you know how particular it is to write the position of the C double bond OO in ester. In this structure here, CH2 is on the left of the C double bond O. CH3 is on the right hand side of the O. But in structure of B, CH3 is on the left hand side of C double bond O and CH2 on the right side of the single bond O, okay, which is not correct. So B is also incorrect. Now let's look at C. CH, okay, CH again. OH is correct. This part is now correct. CH2, CO2, CH3, suggesting CH2 is on the left hand side of single bond O. CH3 is on the right hand side of the single bond O. Okay, this part is also correct. Yes, so let me circle it, correct. And this R group, the last one, the R group can be any alkyl group. In this case, is an ethyl group, CH3, CH2, also correct. So C is the answer. Let's look at why is D incorrect. We have the OH. Okay, OH should be bonded to CH, but here C is missing off the H. Okay, it is actually bonded to two R groups instead. So that means for D, okay, the reaction didn't start with an aldehyde. It starts with a ketone, okay, which is not wanted in this question. So D is incorrect.